Hi everybody. This is just going to be a really quick introduction to our next unit and the core ideas. And our next unit is dynamics, and dynamics is just the study of forces. And so forces is any kind of push or pull. So maybe as a first thing, pause the video right here and try to list in your notebook as many different kinds of forces as you can possibly come up with. I think it's a good exercise just to get prepared. Okay, hopefully we're back and we have some good list of things you can compare with your classmates later on and see what sort of stuff you came up with. But what do we need to know about forces? Well, I'm all alone here, so I have to play the vector scalar game alone. So force, is it a vector that has both an amount, magnitude, and direction, or is it a scalar, something that only has magnitude and no direction? Well, here's a quick way to think about it. I want you to, whatever you have in front of you, like a desk or a table, whatever you've got, I want you to push on it with no direction. Yeah, you probably can't do that. Forces have to have direction. They're definitely vectors. Alright, let's try the unit game. This one would just be a complete guess for most people, but luckily, I'm a physics teacher, and I happen to know that the unit for force is the Newton, abbreviation capital N. Now, we don't talk about a ton of scientists in this course, but Newton's going to be an exception because all the laws we're going to be using in this unit are named after him, so he's going to have to come up in some form or another. Okay, so if a video with both the vector scalar game and the unit game didn't make you excited enough, this next part is really great. We get to start talking about free body diagrams. You're going to become so familiar with these, you can just abbreviate it FBD. It is the key skill of this unit. In fact, I found that if ever you're stuck and someone asks you a question like, what do you do? What's going on right now? If you just say free body diagram, about 50% of the time you'll be right, and that'll be the right next move. 50% of the time it won't work, but if you're ever in doubt or at a loss, draw a free body diagram. And they're pretty simple. We've already established that forces are vectors. A great way to represent vectors is with arrows. There are two parts of a vector. There's a direction and there's a magnitude. Arrows are great because they point in a direction. The direction that they point in is the direction of your vector. They're also great because you can make a little arrow or a big arrow. The bigger the arrow, the bigger the force, the bigger the magnitude of the force. So let's say that this force is sort of pointing that way and is distinctly smaller than this force, which is pointing that way. So a couple very quick rules about free body diagrams. All the forces, no matter what, should come out of the center of the object. So I'm going to give you a little example here. Let's say that there's a giant box, and then here I am pushing the box. Now, so there's a pushing force from me. It's coming from this side, but I'll draw it as an arrow coming out of the center of the box, because all of my arrows will come out of the center of the box. What are some other forces that we might put on this? Well, gravity is going to pull downwards on the box. So I'm going to label force of gravity. If it's an actual surface, there's probably some kind of frictional force pointed in the opposite way of my push, if I'm pushing it this way. So the force of friction will go this way. And last but not least, there's something called the normal force. And the normal force is a force that a surface will exert on an object. So this is sitting on the ground's pushing up on it. We call that the normal force. Now, it's not called the normal force because it's a typical thing that would be there, you'd expect it. It's normal because it always acts perpendicular to the surface that it's on. So the two rules that you need to keep in mind when drawing free body diagrams, they come out of the center of the object, And they always need to be labeled with a name. You can't just have blank number of newtons next to your arrow. You have to label what's actually causing the force, whether or not it's gravity or the normal force, or just a regular pushing force, or a force of friction. And that's, I think, hopefully all you need to know before you jump into the Newton's first law packet. Good luck.